In this lecture, we will cover the encoders that you will use for the segmentation. As you know that segmentation architecture consists of encoder and decoder architecture. These encoders are available in the segmentation model's PyTorch or SMP library. As we know that a complete segmentation model or segmentation architecture follows the encoder and decoder architecture. So what is encoder? The encoder is mostly a convolutional neural network which extracts the meaningful feature map from an input image. Also, it increases the number of channels in each step and downsample the image, means reduce the height and width. And on the other hand, what is decoder? The decoder upsample the feature maps obtained from the encoder and decreases the number of channels and outputs a segmentation map which is the region of the pixels of the same size as the input. So as previously we have seen the transfer learning concept for the encoder part. Now you will cover the different pre-trained encoders with the transfer knowledge from the ImageNet dataset that you can use for the segmentation. Because it's a common practice to use a pre-trained encoder in the segmentation rather to define your own encoder, and pre-trained encoder give the good results. So in the research, the common practice is to use a pre-trained encoder and define your own decoder, or propose or introduce your own decoder to perform the segmentation. The first encoder is ResNet. Using ResNet, we can extract the feature with 256 channels and the downsampled spatial resolution of the original image 1/4. Similarly, we can get the 512 feature map with the downsampled spatial resolution 1/8, and you can also get 1024 feature map with the downsampled spatial resolution 1/16. And finally, you can also get the feature map with 2048 channels and the spatial resolution of the original image downsampled 1/32. So with the increase of the number of channels, the spatial resolution is decreased, and on the other hand, feature becomes strong. The ResNet encoder is a convolutional neural network architecture that was developed by the researcher at Microsoft. It is commonly used as the encoder part of the convolutional autoencoder for the image classification and semantic segmentation. The ResNet encoder is known for its use of residual connections, which allows it to train very deep networks without suffering from the vanishing gradient problem. This makes it possible to train very accurate models with a relatively small number of parameters. The ResNet encoder is known for its good performance on large-scale image database. Then we have the ResNext encoder. ResNext is a variant of the ResNet encoder, which is a convolutional neural network architecture that was developed by the researcher at Microsoft. It is also commonly used as the encoder part of the convolutional encoder for the image classification and segmentation tasks. The key difference between ResNet and ResNext is that ResNext uses the group convolutionals, which allow it to scale up the model's capacity without significant increase in the number of parameters. This makes it possible to train very accurate models on large datasets. Similarly, we have the ResNest, Res2Next, RegNet, JerNet, CNet encoder. The CNet encoder is a convolutional neural network architecture that was developed by the researcher at Hawaii. The CNet encoder is known for its use of squeeze and excitation blocks, which are blocks of the layers that use global average pooling, and two fully connected layers to recalibrate the feature maps produced by the convolutional layers. This allows the model to attend to the most important feature in the input image, which improves its performance on a variety of tasks. Then we also have the SK ResNext and DenseNet encoder. The DenseNet encoder is convolutional neural network architecture that was developed by the researcher at Facebook, can be used for the semantic segmentation task. The DenseNet encoder is known for its use of dense connections which connect each layer to every other layer in the network. This allows the model to reuse feature learned by the earlier layers, which makes it possible to train a very deep network without significant increasing the number of parameters. Then we have the Inception encoder. The Inception encoder is convolutional neural network architecture that was developed by the Google, can be used for the semantic segmentation task. The Inception encoder is known for its use of inception modules, which are blocks of layers that use a combination of 1x1 convolutions, 3x3 convolutions, and max pooling to extract multi-scale features from the input image. These features are then fed into the series of fully connected layers. Then we have the Efficient Net encoder in the list. The Efficient Net encoder is a convolutional neural network architecture that was developed by the researcher at Google, can be used for the semantic segmentation task. The efficient encoder is known for its use of compound scaling, which allows the model to scale up its capacity while maintaining good performance. This is achieved by scaling the model's depth, width, and resolution in a balanced way. Then we have the mobile net encoder. The mobile net encoder is a convolutional neural network architecture that was developed by the researcher at Google, can be used for the semantic segmentation task. The mobile net encoder is known for its use of depth-wise separable convolutions, which allow the model to be very efficient in terms of the number of parameters and computational cost. This makes it suitable for use on mobile and embedded devices where computational resources are limited. Then we have the DPN encoder and VGG encoder. The VGG encoder is a convolutional neural network architecture that was developed by the Visual Geometry Group at the University of Oxford, can be used for the semantic segmentation task. The VGG encoder consists of a series of convolutional and max pooling layers which extract hierarchical representation of the input image. These hierarchical representations are then fed into a fully connected layer. The VGG encoder is also known for its simplicity and good performance on a variety of tasks. And the last encoder is mixed vision transformer. So all of the encoders we have seen previously, they consist of the convolutional neural network except this mixed vision transformer. This vision transformer encoder is a type of transformer architecture that was developed for image classification, segmentation, and other different computer vision tasks. It is based on the transformer architecture which is commonly used in natural language processing. Unlike convolutional neural network architecture which use convolutional layers to extract the hierarchical representation of the input image, the vision transformer encoder uses self-attention layers to learn global relationships between the image pixels. This allows it to achieve good performance on a variety of tasks without requiring the use of hand-designed architecture or modules. However, the vision transformer encoder is known to require a large amount of computational resources, so it may not be suitable for use in all scenarios due to computational cost. So all these encoders you can use with different decoders that we will see after this. But the question is, which encoder will be used? The answer is ResNet because it is the most commonly used architecture in the research for the segmentation purpose. I will go with the ResNet architecture. We have already seen the detail of the ResNet architecture, but you will use all the encoders listed over here while defining the segmentation model. There are different ResNet encoders are available. For example, here you can see ResNet with 18 layers and it is trained on the ImageNet dataset with 11 million parameters. ResNet with 34 layers, trained on the ImageNet dataset and with 21 million parameters. ResNet 50 with 50 layers, trained on the ImageNet dataset with 23 million parameters. ResNet 101, trained on the ImageNet dataset with 42 million parameters. And finally, the ResNet 152 with 152 layers in the architecture, trained on the ImageNet dataset with 58 million parameters. So you can try different encoders according to your dataset and according to your requirement. But mostly used in the research is the ResNet 50 architecture because you can see it has the average number of parameters and will give the competitive results. Here you can see as the number of layers increases, the parameter increases. So next you can see the DenseNet encoders. There is DenseNet 121 trained on the ImageNet dataset with 60 million parameters. DenseNet 169 trained on the ImageNet dataset with 12 million parameters. DenseNet 201 trained on the ImageNet dataset with 18 million parameters. DenseNet 161 trained on the ImageNet dataset with 26 million parameters. So here you can see the VGG pre-trained encoders. VGG 11 trained on the ImageNet dataset with 9 million parameters. VGG 13 trained on the ImageNet dataset with 9 million parameters. VGG 16 trained on the ImageNet dataset with 14 million parameters. And VGG 19 trained on the ImageNet dataset with 20 million parameters. And next is the Inception encoders. The first one is Inception ResNet v2 trained on the ImageNet dataset that consists of 54 million parameters. Inception v4 trained on the ImageNet dataset with 21 million parameters, and Exception trained on the ImageNet dataset with 22 million parameters. So here you see each encoder have different versions. Further, all these pre-trained encoders trained on the ImageNet dataset are available in this SMP library that you can use. And when we will define the segmentation model, we will see how to use these encoders with different decoders that we are going to cover in the next lecture. See you in the next lecture.